Here in this first segment, dealing with concepts related to absolute value, we're going to work with just the general concept of what absolute value is, and then apply that to evaluating some expressions. So to begin with here, what we define absolute value to be, so definition right here is that absolute value is going to specify the distance that something is from the number 0. So that something I'll just refer to as a quantity, let's say. So it's the distance of a quantity from 0, the number 0. And that's how we'll define absolute value. So like, for example, if I pick the number 3 right here and I plot it on the real number line, clearly, to get to 0, or the distance from 3 to 0, is a distance of 3. And so the absolute value of the number 3, therefore, then, is going to be 3. So the symbols that we use for absolute value is we use straight bars. So it'll look like this, and those are the absolute value symbols. And so then if I put the 3 inside of that, what I'm really trying to find is the distance that 3 is from 0. And so this is equal to the number 3, because that is the distance of it from 0. Just as another example, like if I pick this number right here, this is negative 4.5, and the distance that negative 4.5 is from 0 is 4.5, right? Distance can't be negative because you're not going to travel, negative 4.5 miles to get somewhere, right? It's going to be 4.5. So if I were to take negative 4.5, and then I put those bars around it, which is absolute value bars, but what that means is the distance of that number from 0, it turns out that this is going to have a value of 4.5. And then, of course, as a special case, if we were like at 0 and we wanted to take the number 0 and then find the distance of the number 0 from 0, of course, that's 0 away from 0. So that's just going to equal 0. So if we just kind of had to summarize like what's going on with absolute value, basically we could just say this, that if I pick any number x, and then I find the distance of that number x from 0, it will equal the same number x only if x itself is going to be positive. So if x is greater than 0, right? But then otherwise, it's going to equal its opposite if that number x is less than 0. So like, as some examples to kind of reinforce right here. So if I do actually pick a number that's positive, so like 6, okay, then it's going to equal the same x, right? But if I do pick a number that's negative, so the absolute value of negative 6, it's going to equal negative of negative 6, which of course is going to equal 6, right? Now, I guess we do have to do something about the 0, so we probably could just, I don't know, maybe put it equals to right there, and then that will hold, of course, right, when x is 0. All right, so just some examples of evaluating expressions with absolute values, some simple ones to begin with, and then the last one's just, I don't know, a few steps involved. So yeah, if you're just finding the absolute value of 5, it's just going to be 5, right? And if you've got a negative number inside of it, it's just going to be 7.5. So absolute value is always going to keep it positive, or if it's not positive, turn it positive, right? And then the only kind of exception when it wouldn't be positive is if it's 0, because then the absolute value of 0 is just 0. Okay, so those first 3 should be pretty straightforward. So then moving right here, so when you've got a negative in front right there, what that really means is this is the same thing as negative 1 multiplied with that quantity of the absolute value of 3/4. And so we do have order of operations that kind of really comes into play right here, because what you have going on right here is technically we consider absolute value bars to be grouping symbols. And so we've got a grouping symbol there, and then going on like right here, you've got multiplying. And so based on the order of operations, which I have summarized up here, right, we need to do the grouping symbols first, and then multiplying is going to come later on. So if we do the grouping symbol part first, you actually have to do this part right here, which is to find the absolute value of 3/4. So if I just focus on what I circled in the black there, the absolute value of 3/4 is 3/4. So I'm going to change it to 3/4. It no longer has the absolute value, but then we have that negative that was in front of it, which means taking negative 1 times that. And so what we'll come up with then as a final answer is then negative 3/4, right? So because there's that negative on the outside, right, then of course we're going to get a negative answer after the fact. Let me do some highlighting in green here, just so that we know like what's highlighted is the final answers there. All right, excellent. Okay, you got to be really careful with this one right here, because a lot of people will probably tend to think, oh, there's a negative, and then there's like basically a negative right after it, so it should just be positive. But that's not going to hold. It's because of the same thing in the previous example that we just did, that right here, you've got a grouping symbol. And we've got to do that first because of the order of operations. So that's got to happen first, and then second, we'll take care of the multiplying by the -1. So first, just what I circled is the absolute value of the negative square root of 2, which is going to be positive square root of 2, and then we'll take care of that negative in front of it, and that's basically your answer. So it does turn out that we get a negative answer right there, and that we can't do negative makes a positive here, because that's not what is happening here. All right, pretty straightforward right here. You just have absolute value of 10 going on right there, and then you also have a separate absolute value. It kind of looks like, oh, can we do negative and make it plus? And you can't, because again, grouping symbols have to happen first before that operation, which is a subtraction operation, right? So if you find what this is right here, this is the absolute value of positive 10, it's going to be 10. And then if you find what this is right here, this is the absolute value of negative 10, which is 10. Now we found that. Now you can carry over that subtraction operation. So now we've got this is equal to 10 minus 10, and 10 minus 10 is equal to 0 as a final answer there. Excellent. Okay, so with this one right here, I want to point out, and I'll say, like, this is going to be the wrong way of doing the problem first, because probably what you think you might want to do is, like, do that maybe and distribute, and this ends up being wrong. So again, I'm doing this incorrect right now, guys, because if you were to do this the wrong way, you would get 2 times -7, and then plus 2 times 4, which would be what, -14, plus 8, which would be -6, right? And all of that is the wrong way of going about this particular problem. The reason why you can't distribute right there is because right there, right, we do have a multiplication operation because we're trying to multiply by 2, but we also have these absolute value bars, and we've got these grouping symbols. And we know in the order of operations, the grouping symbol has to happen first before we can multiply. So what I circled in green has to happen first. So the right way of going about this problem is to, within that grouping symbol, figure out what we've got. So you've got -7 plus 4 is a -3. Now that's still an absolute value, right? So we really haven't finished the grouping symbol aspect yet. We've got to take the absolute value of that -3, which is going to be +3. And then we can take that 2 and multiply it by 3, and that's going to give you this final answer right here of +6. And that's the right answer, so let's get the right color for that. Okay, perfect. All right, one last one right here. So I just wanted to make sure we get an example that kind of has all of the steps of order operations involved, so that we get a flavor of that with absolute values going on right here. So yeah, as we evaluate this expression, right, you should always be thinking about following the order of operations. And so what we'll consider here first is whether or not we've got any grouping symbols, and we definitely do, because you have these absolute value bars, which is a grouping symbol. So we want to worry about that and only that. So we can't do any subtracting yet, we can't do any multiplying, we can't do any exponenting yet, right? All that stuff is going to stay the same. So I'll keep that in like the color black, basically. And then we'll just kind of worry about the absolute value of 2 minus 7. So you can think, okay, 2 minus 7 is -5, but then we got an absolute value of that, so that's going to turn into +5. So now that's the only thing that's changed. I'll just kind of put parentheses there. Okay, so the next thing in PEMDAS, or order of operations, would be to do the exponents, right? So that's the only thing that we want to worry about right now is now, okay, let's square, right? So we're only going to square the 5. So when you square 5, you're going to get 25. And then we'll put that in parentheses, and then the 3 and the 9 minus. So everything else is the same, right? Okay, so now we've got multiplying and dividing, and that's going to happen right here. You've got the 3 and the 25 right there. So when you multiply that, that's going to give you 75. And then we're going to go ahead and then finally do the last step of this, which is to subtract the 75 away from the 9. So taking care of the addition, subtraction aspect of this, It's going to give you a final answer there of negative 66.